Hello everyone, Alex with BIMitUp here. Today we're going to be talking about MV parts. I'm going to show you how to create MV parts in AutoCAD MEP. I realized that I've been spoiling my Revit viewers and I have a treat for my AutoCAD MEP viewers. So today I'm going to show you how to create MV parts from beginning to end in AutoCAD MEP. First I want to give you a quick introduction. We're going to go over how to delete MV parts in the catalog. I'm going to show you how the AutoCAD MEP catalog works. I'm going to show you how to prepare the image so that you can quickly find your equipment while you're designing in AutoCAD MEP. I'm going to show you how to generate and prepare 3D geometry in AutoCAD. I'm going to show you how to create the blocks in AutoCAD MEP. And finally, we're going to create MV parts in AutoCAD MEP. For that, we're going to create the connectors so that the pipe knows which way it's going and in which direction and which type of connector it's using, whether it's a groove connection or a threaded connection or anything else that you need. And then I'm going to give you a ton of tips and tricks, a ton. I guarantee you that there's nothing like this in YouTube. This is the best video in MV parts. I'm really proud of it, and I hope that you enjoy watching it as much as I enjoy creating it for you. Let's get it started. So what you want to end up with is you want to be able to come here to equipment, and then you'll see that under my install MV parts, these are my Alex fire protection MV parts. Under those I have deluge, and then I have package, right? All these are available for purchase at BIMitUp.com. So this will be one that is completely ready to go inside of a cabinet from Tyco. You have the valve only, and this one in particular is the grooved one. This one's the flange one by Tyco. And then what we're going to create today is the Viking F1 valve and trim, vertical trim, which is the valve and some peripheral components, you know, a drain, a little bit of piping, a gauge and other stuff with grooved connectors. And what happens with that is that you want to be able to just place your part and have all the connectors, all the intelligent pipe connectors ready to go. So you want to be able to connect a groove pipe right here, you see, and then for the outlet you also wanted to connect a groove pipe, and then for the drain outlet you want it to be a threaded pipe, and you will be ready to go. Okay, so let's get to it. And before we even start, think about it. It makes sense. If you like this kind of content, make sure you subscribe to the channel. You can hit that bell so you get notifications and you don't miss any of our videos. And for that I'm going to delete this. I'm going to remake it. Okay. And how do we delete something from the catalog? For that you would have to navigate to your ENU folder, which is typically located somewhere like this. See program data, Autodesk. Gotta be careful because this program data folder is by default is invisible, so you have to make sure you make it visible, or you simply type it. Okay, so Autodesk MEP, whichever release of MEP you have, ENU MEP content. So in my case I'm in the United States, so I have US Imperial, and then under MV parts you can see that I have, in my case, this is a folder I created, Alex Fire Protection, which contains all my MV parts for fire protection. So in this case, you would go to deluge, right? And let's study a little bit the AutoCAD MEP catalog structure. When I come here, you'll see that we have three files. Okay, one of them is going to be the BMP file, which is just an image file that you use to identify visually the part that you want to insert, something familiar, something representative. And then you have the DWG file, which actually contains all the DWG information of the MV part. and then you have the XML file which ties everything together. So if I were to open the DWG file, you will see that that file contains all the 3D blocks, which are these guys right here. Like if I let me move it out of the way so you can see it, right? So that's the 3D block of each one of my sizes. So it would be 3, 4, 6, and 8 in this case inches. And then you have each one of the projections of that 3D image into a plan, whether it's the back, in this case this will be the back block, this would be the left block, right? This would be the front block, this would be the bottom block, this would be the top block, and then finally this one here would be the right block, right? And this is what AutoCAD MEP is going to use to display your part, whether you're looking at it from the front, right? So if you're looking at it from the front, it would show this here. If you're looking at it from the top, it would show this one here, and so on. And we'll see a little bit more of that later on, but for now I just wanted to show you what lives in that DWG file. And like I mentioned, accompanying this DWG file, there are the BMP file, which is the image file, just for identification purposes. And then you have this XML file that if I open it with an editor, let's say Notepad, you'll see that it's, just a little bit of coding that tells AutoCAD where the connectors are located, and where the image is located, and all that. And we'll get a little bit deeper into that in our course. So for now, let's just go ahead and delete this whole folder. And notice that if I do that, even when the folder doesn't exist, if I come here to my MV parts, AutoCAD MEP will remember the structure, right? But then now I don't have that information available, right? So if I click here, you see I don't have those images. I don't have the DWG file. I don't have the sizes. I don't have anything because I deleted everything from the folder. So if you want to clean this up, what you would have to do is go to Catalog Region, and then in my case I just want to regenerate the MV parts, and it's just going through the catalog to make sure that everything's up to date. It's like a sync, right? So we're good. And if you go now under Deluge, you'll see that now you only have the package and the valve only information. You don't have the valve and trim, which is what we just deleted. So let's go ahead and create it. The first thing we're going to do for that is we're going to search for that image. Okay, so we know that's going to be the Viking F1 deluge valve with trim. And then it should be an image just like this one. So let's go to images. And here we go. This one's pretty good. So I'm going to save the image as, in this case, by default, my Windows has it as is a JPEG file. So I'm just going to save it in the downloads folder as deluge F1, right? But AutoCAD MEP doesn't like JPEG too much. So what I do, or at least up to 2014, it didn't. I stopped trying. I just simply know that BMP works well. So I'm going to open it with Paint or any other photo editor and then save as BMP with the same name is okay, and click save. Now we have our image available for whenever we need it. Now let's go ahead and create the geometry for that. And for that, let's go ahead and find that geometry. So I'm going to go to the Viking website, and I can see that here they have the Revit files. So I'm going to download them. So let's check it out. Let's see what it contains. And then you see that in this case, this type of Revit family contains the RFA, which is the extension for a Revit family, and the TXT file, because in this case this is a type catalog family. So what that means is that you cannot simply drag and drop this into a Revit file, into a Revit project. You would have to import it and then make sure you select the parts that you want to import. So let's check that out. Just in case I need it, I'm going to download the technical data sheet as well. So I'm in Revit now, and what I'm going to do is go here to File. I'm going to create a new project. It doesn't really matter which template you use, because in reality what we want to do is just acquire the geometry from the Revit file. We're not going to do anything with piping or ductwork or anything. So, but just for consistency, I'm going to use a mechanical template and click OK. Make sure you stay in project, because that's what you want to do. You don't want a project template. So let's do OK. And now our blank project is open, and we want to insert our family. So how do we insert a Revit family? Well, we come here to Insert, and you go to Load Family, and then you navigate to that location. In our case, I have it under Download. And in this case, remember what I told you about that text file? Here from the Revit navigation bar, you only see the .rfa files, which is this one. But in the same folder, there's that text file, you remember? And that's what's going to allow me, if I click here and I click Open, to have this dialog box here that tells me, okay, out of all the families that I have available for you in that Revit family file, which models you want to bring in. So in our case, we're gonna go with grooved 3-inch, 4-inch, 6-inch, and 8 inches. Okay, so that would be the 3-inch grooved. Actually, we want it with trim. So let's see if we can find that. Oh, these are no trim. So we want the grooved with the vertical trim. So here it is, grooved with vertical trim. Control, groove with vertical trim. 6-inch groove with vertical trim, and 8-inch groove with vertical trim. So let's click OK. Notice that it's upgrading from 2017, which is the release that the family was created on by Viking. Okay, now the family is in our project, but we haven't dropped it in our model yet, right? It's in our project navigator. So let's see where that family is. And before that, you know what I'm gonna do? I'm gonna open the family itself, right? So I'm gonna come here, I'm gonna double click in that family. Yeah, I'm gonna upgrade the model. So in this family, I can take a look at, for example, the 3D view, the preview, so I know what the family contains. It looks really nice. And I can see that it has the connectors. These are Revit connectors. This is not going to be useful for us. I just want to take a look. I want to preview what geometry is contained here, right? And then if I come here, I can see the parameters, and notice that it's a bunch of formulas, and all this is going to be driven by. See, if I come here and I look for the types, I won't see the 3-inch, 4-inch, 6-inch, and all the different sizes, because this is driven by that TXT file that I told you about. Okay, but one thing I do want to check is up here where it says family category and parameters. I want to make sure that I know what we're dealing with. We're dealing with a pipe accessory. That's how Viking categorized it. Okay. So pipe accessory, and now I know I'm going to close the family. I don't need this anymore. But I just know for sure that I'm going to be able to find my family under pipe accessories. And here it is. See, Viking, deluge valve, model F. So what I'm going to do is drop them in some kind of like a consistent way. So right now I'm going to drop it here. So this would be the 3-inch, right? I'm going to change my level of detail to fine, and I'm going to keep this as wireframe, just so I know in which orientation I'm dropping things, right? So that's my 3-inch. I'm going to drop now my 4-inch, right? More or less aligned, you know, it doesn't really matter too much. I'm going to leave a little space. Then I have my 6-inch. This doesn't have to be perfect because we're not going to be using this after we create our part. Okay, and then my 8-inch. I'm going to drop it here, and then I'm going to put this in a 3D orientation. Right, let me keep this as a fine detail level. Let's take a look. That's looking pretty good, right? So this is all the geometry we want to export. Okay, so for that we come here to File, Export, CAD format. It's going to be a DWG file. And one thing that many people struggle with is that they export this geometry and then the geometry is mesh and they cannot use it, or surface, and they cannot use it in AutoCAD MEP. They have a lot of problems. So in order to make sure that your things are going to work, you want to come here, and then here under the Solids tab, you want to make sure that instead of Polymesh, this is set up to ACIS Solids. Okay, and that's because AutoCAD MEP understands solids very well, but it doesn't understand Polymesh too well. Okay, so just click OK, then Next. So let me go to that Downloads folder where everything else is, and I want to be able to name my file. I'm going to call it Viking, actually it's Deluge, I believe it was F1. This doesn't really matter too much, it's our temporary files, okay? But I'm going to make sure to identify this as a Revit export, and you'll see why in a little bit. And I don't want to, well, in this case there are no links, so it doesn't really matter, but you always want to have this unchecked. If not, you create a mess. So let's click OK. It's going to take a while because it's exporting all this geometry to a DWG file. Our export is done. Let's make sure we have it before we close this Revit file and forget about it. So let's go to Downloads, and here it is. We don't need this zip file anymore. We don't need the JPEG anymore. So let's double click in here and let's see what this has. There we go. So this is my exported 3D file, and as we can see, we have the geometry we need. You know, you want to see it a little bit better, you can change here your visual styles. You can use realistic if you wanted to, but this is really heavy. You can use hidden, and hidden is really nice because it hides things behind it, but it taxes your system a lot. It takes a long time, so I typically keep it under visual styles conceptual. It's a little bit faster, and you know, it lets me see things well. So very well, we have our 4 blocks and we're ready to go. So we don't need that Revit file anymore, so I'm gonna delete it. So what you want to do is clean up these blocks and, you know, have them so that they comply with your standards and all that. And for that, the best thing is to open a brand new file, and then I'm gonna come here back to the file that contains the geometry, and notice that if I click on this and I go to properties, this is the block already. Right, it has a name. Like if I were to double click on this block, it has a name already. It's really nice, and it's really tempting to use this block as it comes, but I highly discourage you from doing that. What I would recommend is to grab all these blocks and then you burst them, and the difference between a burst and an explode is that burst is a little bit lighter. You know, explode tends to break things to the minimum, and sometimes you lose some smart geometry that you may want. So always try burst first. Okay, so I'm gonna do burst, and this is gonna take a little bit because it's bursting all that information. All right, and now what you want to make sure is that, let me go to my 3D view. You know, we don't care about these levels, so let me just delete them. Delete this, we don't need that. Actually, this information here is noise. You know, you could delete all that. And notice that this is in a different layer, so you might be able to isolate that layer and then delete that from each one of the blocks. You can even do them all at once and then unisolate that. Right, and now we have a very clean geometry. And if you click on the valve, for example, what you want to see is you come here to properties, and this is a beautiful 3D solid. It's not going to give you any problems in the future. It's going to behave exactly the way you want to. And you want to make sure you have a spot to host your connector. So this will be the inlet, this will be the outlet, and then this will be your drain port, your main drain port. There's a little bit of a drain port here, but you don't really care too much about that. You care about the inlet and the outlet mainly, and the drain port. So for this particular family. So now we have our geometry, and we can take it to our other file. What I'm gonna do is take all this geometry, right, and I'm going to copy to my clipboard, and then I'm gonna go to my blank file, and I'm gonna do paste to original coordinates. And then one thing I like to do, and this is not necessary at all, it's just I like doing it, is I select my smallest family, and then I move it from a representing point like the inlet of the valve to 0, 0, 0. And that's just my nature, you know. I like to have things with a certain origin, but this is not necessary. So now what we want to do is we want to create a block for each one of those sizes. Okay, and one thing that's very useful to keep things consistent is to have, prior to starting creating your part, you want to have the name of the MV part or the folder that you want, and then the name of each one of those parts. And AutoCAD MEP likes to have right after the name of your MV part a space and the word model whenever you're naming your 3D model. And that's gonna help AutoCAD MEP identify which one of these guys you want to create projections of. What I mean by projections is, you know, the top, the bottom, the front, left, right, and back that we just saw. So let's go ahead and create the first. Well, one thing that is also a good idea is you don't want to have this in a weird layer. You always want to have this in layer 0, and you always want to have your colors by layer. Okay, so now we're ready to go. Let's create our first block first. So you select all the geometry, you type the word block, and now I am copying and pasting the information from that Word file that I just showed you, and that's just to keep consistency. So I have my block name here. I want to pick a point, a base point, and that's going to be the insertion point of the block. In this case, it's going to be 0, 0, 0 because I placed this specifically in 0, 0, 0. Okay, but in all the others it won't be. So I'm just going to be consistent in all of them, and I'm going to click pick point, and then I'm going to select that inlet, which is this guy here. Okay, so I click OK, and as you can see, if I double click now this is a block, and the block has the name that I want it. Okay, and this is just a note to remind you that if you're watching this, it means that you're not currently at BIMitUp.com, so you're only getting partial content. If you want the real deal, you can go to BIMitUp.com and you can book some training there, or you can purchase videos either individually or you can buy a whole course. So now let's go with the second one. Again, block. I select now my 4-inch. I'm gonna pick a point for it, and that point is the inlet of the valve. Now let's do the third one, which is our 6-inch. I'm gonna pick a point. Okay. And then finally, I have the largest valve that I want, which is my 8-inch. I'm gonna pick a point right here. Okay. And now, you know, it's always good practice to double click in each one of your blocks just to make sure that, you know, you have this guy, you have this guy, this guy, this guy. Okay. So see, each one of them, it's its own block, and they have the word model afterwards, separated with a space. That's very important. You'll see why in a little bit. So now we have the 3D geometry for our valves in DWG format, ready to create our MV parts. So I'm going to save this file. This is an important file. And I'm going to call it Deluge F1, let's say for MV part creation. And this is a temporary file as well. You'll see why. Click Save. And now we're ready to create our MV part. And for that, you come here to Manage, and then you activate your content builder. Okay. You can also type this in the command bar. And now you navigate to where you want to create this, where you want this to live, which will be, in my case, under Alex Fire Protection, Deluge. And we say we already have package, we already have valve only. What we want to create is valve and trim. So you can click here, and then you can create a new chapter, which is like a new subfolder, right? And I'm gonna call this valve and trim. And now we're going to create what's called a block part. And we see the difference between block parts and parametric parts in the full course. But essentially, if you create a block part, what you're doing is you'll have one different block for each one of the sizes. A parametric part has parameters that drive the geometry. Anyway, so let's go here to new block part, and the name, we said it was gonna be Viking Model F1. So I'm gonna call this Viking Model F1. This is the name. For the description, you know, this is okay. I can call it Viking Model F1 valve and trim if I want to be a little bit more specific or descriptive. We click OK, and now we're ready to start the real deal. So as a type, we can keep this as valve. Don't get frustrated. You know, AutoCAD MEP is very limited as far as how many types it has. But thankfully for this example, you know, this is a valve and the description works. As far as the layer key, we go deep into layer keys in another chapter, in another video, in the full course. But for now, all you need to know is that this is the map that's gonna tell AutoCAD MEP on which layer you want to drop this on. So in this case, the layer key that I'm going to use is called FMV General, right? And this is one that I created. I show you that in the full video, or you know, if you ever want to book some one-to-one training, I can show you that as well. So FMV General, that's good. And now we want this to break automatically into existing runs. Yeah, like let's say you have a vertical line, you would like that to break into it. You know, like if you drag and drop it, that it immediately separates the pipe into before and after the valve. So let's keep this check. And let's go to next. And now if you notice, if I go to the right, you know, this is looking for every single block that I have in my drawing. And what you can see is that the model block is the only thing that I have, which is what I created. Remember why you had to separate it by model? This is gonna tell AutoCAD MEP that based on this 3-inch groove model F1 whatever is gonna create a top block, is gonna create a symbolic block, is gonna create a left or right and all that. And you see them in red because they haven't been created. Okay, now to create them, to generate those blocks, what you do is you click here on generate blocks, and then you go get a sandwich, because this is gonna take a while. And if you're serious about your professional training, go ahead and visit us at BIMitUp.com. At BIMitUp.com, we offer professional training and coaching in mechanical, electrical, plumbing, and fire protection systems. We can also train you in Autodesk platforms like Revit or AutoCAD MEP. So go ahead and visit us at BIMitUp.com, or send me an email directly to the email you see on screen and let us know how we can help you achieve your professional goals. And my recommendation is, whenever this takes such a long time, just go out for a run, go for a walk or whatever, grab a sandwich, and just be patient. That way you don't get frustrated. Anyway, this is over. It created the blocks already. So you just hit OK, and now you see that all those blocks, you know, the top, the bottom, that were in red before, now are black. And that's because they had been created. So now our next step is we go next, and now we have to select that previously drawn image. That's that image that we saved at the beginning. So we're gonna navigate to that location, and it was this one here with the trim. There you go. So this is how you're gonna identify the part that you're going to insert. Now let's click next. And now we need to assign the connectors, the pipe connectors. So for that, you right click here, say add pipe connector. So we're gonna have an in. For now, you know, just keep it bidirectional. For now, let's just keep it undefined. From here, you could select, you know, oh, this is fire protection or whatever. This is not really that important because, you know, you eventually will connect it to the right system anyway. So for now, let's just keep it fire protection. This is gonna be in. This is gonna be the inlet. Just click OK. Now in a similar way, we're going to create an out connector. That's a pipe going out from the valve. It doesn't really matter, you know, the bidirectional in or out. This is not that important because AutoCAD MEP doesn't really deal too much with flow. If you want to be strict about it, the flow direction would be out, right? And that would make sense. And then the system would be fire protection. So if you want to go back to your in, you can click on modify, and then you see that this is in. And if you want to be consistent, you can say that the flow direction is in, but that's not really going to change anything. Anyway, let's add now the drain connector. So that would be your drain connector. Your flow direction from the drain will obviously be out, and then the system type, see that this would be drainage, you know. So would it be drain, would it be fire protection, you know, let's call it drain for example. But this doesn't really matter too much. It's not like in Revit that you can be very specific and then use that for filtering or things like that. Anyway, let's just click OK. And now, so we have created our connectors, and notice that each one of our subfamilies, you know, each one of our sizes has the connector 1, connector 2, and connector 3, which were in, out, and drain. So now we need to edit those connectors, right? We need to edit a placement. So we're going to start with the 3-inch. So I'm going to do edit placement, and I'm going to double click on the scrolling wheel so that I can see some geometry. And right now the position is in the correct position, but in general terms you would type P for position, then you would give it a position, right? It would be the center of this face, and then you would type N for normal, right? And I like to keep the ortho on, and then you just have to give it the direction. You don't have to touch specifically in the vector. You can click like here and here, you know, you're just giving it the direction. You're specifying a direction. So that would be the N connector. Notice that it is set now the connection type as undefined, but we know that this is grooved. Okay, so that's a grooved connector. Now we can go to the out. So for that we go again P for position. We position it in the center, and then normal, you go this way, and notice that you're giving it the direction on which the pipe is gonna grow, not necessarily the direction on which the fluid is gonna enter. Okay, this is the direction of pipe growth. Okay, this is also going to be grooved. And oh, we forgot to change the pipe diameter in the other one. So let's go to our end connector, and then we know this is a 3-inch. So here just select 3 inches and then 3 inches as well. I don't think you have to use the symbol of inch. See, like it doesn't really matter. Now let's go to connector 2, and that was also 3 inches, right? And then your drain size. First we need to specify the position. So I'm going to specify the center of this face, you know, because here I don't have a circle or an extrusion, like I cannot select the center, but it doesn't really matter. You won't see it anyway. It's going to come out of the solid. So this is a perfectly fine place to place a drain. And now you need to give it the normal direction, and it's from here to here. And then we need to give it a size, and we know that the size for this is 1.5 because we saw it on the cut sheet, right? So 1.5, 1.5. Now let's go to the 4-inch. Again, double click the scrolling wheel, and then we have the position. The position is correct already, but I'm gonna do it anyway. So position, center, it would be this point. The normal is this direction, and now I'm gonna specify a size for this. This is remember, this is grooved, so I have to change it to groove. This is 4-inch. This is 4-inch. Now let's go to our out connector. So position, center, normal orientation from here to here. We want to give it a size. It's a 4-inch, and it's going to be grooved. Now let's go with our drain. So again, position, I want it to be located here, and the direction of pipe is this way, which is down. This was a 1.5 inch. No, this was a 2-inch, I believe. You can change this in the future anyway. So, but for now we know it's a 2-inch. Oh, by the way, we're keeping this drain as undefined, and we're gonna play with that a little bit later. Just want to show you something. Now let's go with the 6-inch. So again, double click the scrolling wheel. We need to start with our end connector. So the position is going to be the center of this face of the cylinder. The normal direction is this way. We know that this is a 6-inch, and we know that it has to be grooved. Now let's go the out connector. This is P for position. It's gonna be here. The normal is already in the right direction, but I'm just going over it anyway. This is going to be a 6-inch. and we know it's going to be grooved, and we're missing our drain. The position of that drain, as we mentioned before, is going to be right here, and the normal is downwards. It's a 2-inch pipe, and we're going to keep it as undefined. Now the last one is the 8-inch. Notice that this one's flipped around. So for some reason Viking decided to flip it around on us, but it's good, it's okay. So the position is still gonna be that same location. The normal vector is this way. It's going to be an 8-inch pipe, and we know that is a grooved connection. Similarly, let's go to our out connector. The position is right here. The normal is this way. This is an 8-inch, and it's going to be grooved. And my final connector is going to be that drain is on the other side now. So you know, I'm gonna orbit a little bit away from it just so that I can see it. It's right here. So that's the main drain. So I go to drain, and the position is the center, and the normal is this way, and it's a 2-inch and 2-inch. Now we hit OK, and we have all our connectors defined. Let's hit next and finish. There we go. So now this file that we had, that was for MV part creation, I can close it. I won't ever need this file again if I did things right. So I'm gonna click save just to have it around. And we're going to close this file as well. This was the Revit export. We don't need this either. I'm gonna open a new file, and let's see what happens, right? If I go here to my MV parts catalog, and I go to deluge, I do see that here. See, valve and trim. When I click it, these are heavy parts. It takes a little bit. And there you go, here they are. So if you don't see them, it's because you have to regenerate your catalog. And the way you regenerate your catalog is you type catalog regen, and then you type MV parts, the M for MV parts. Otherwise it will regenerate the whole catalog, and it takes a while. Just want to do the MV parts. And it's a good practice to regenerate every time you create a bunch of MV parts, to have your catalog as up to date as possible. Perfect. So now let's give it a shot. I'm gonna go to my 3D environment, and I'm gonna drop it on plan view. Doesn't really matter where you drop it, but I'll drop it using the plan view. And I'm going to drop a 4-inch groove, and let's drop it at 3 feet of elevation, right? So here it is. Again, I like to keep this ortho active. Makes my life a lot easier. Let me do double click on the scrolling wheel, and now you can see that you have your add pipe option here. You see that little cross there? You can click in there, and that's taking your grooved piping out. So let's make sure we're on the correct routing preference. In this case, I have grooved and threaded. That's perfect. And this template is available for purchase at BIMitUp.com. So I come here, and there it is. That's my grooved connector. Let me, change a little bit my visual style so you can see the groove fitting. You see it right here. And then out of this one, I also have grooved, right? And I could start, piping, you know, wherever I want to go. Now on the drain connector, remember we had kept it as undefined. This is a little bit tricky. Like in this case, I'm going to take it down, and you see how it, you know, it places this adapter here. If I go to properties, this is a threaded adapter. So let's see if we can fix that. So to fix that, let's go to manage and then back to our content builder, and then click on our family, and let's click here on modify part size, and then you go to the connectors tab, and then here we're gonna change the connector, the drain, from undefined you can change it to none, and it would work as well, or you can change it to threaded male pipe thread, and that's what we're gonna do. I already changed it to the 3-inch one, I believe. Let me see. Yeah, see, threaded male, this one threaded male, and then this one threaded male. Okay, now we click on OK. Okay, and we need to regenerate our catalog, and for that again you type catalog regen and then M, so that it regens only the MV parts and not the entire catalog, you know, with piping, ductwork, everything. And that takes a long time. It's not that bad. Alright, so let's give it another shot. We go to equipment and let's drop in our project, a 4-inch grooved. Actually, let's do a 3-inch. Right? So let's see, let's test our in connector first. There you go. See how it provides the grooved coupling there. That's pretty good. Let's do the same for the out pipe, the exiting pipe. Perfect. There you go, ready. And then the drain connector, and that would go most likely through the wall out to the grassy area or something like that. Okay, so that's how you create an MV part in AutoCAD MEP. I hope you enjoyed it, and I'll see you soon. And as always, if you enjoyed the video, make sure you smash that like button down there, subscribe to the channel, hit that bell so you get notified. Thank you for watching, and see you in the next video.